Hello everyone and welcome back. In this lesson, we're looking at solving logarithmic equations. And so we're going to spend some time looking at the different principles that are needed to make sure that you understand exactly how to go about solving these logarithmic equations. We're going to start off with a very, very simple example, and that is we want to solve the exponential equation 3 to the x equal 9. Now, you're probably wondering why we're solving exponential equations when we're talking about logarithmic equations. And that is because logarithmic equations and exponential equations are related. So let's start by solving this equation 3 to the x equal 9. And so we can solve it by saying, let us write 9 to the base of 3. And so in doing this, 3 to the x equal 3 square, which is the same thing as 9. And therefore, because the bases are equal, we understand that the powers would be equal. So in this case, x is equal to 2. But we could use logarithms to solve this. Not that it's needed in this particular example, but just to show you how it works. So we could solve it by saying that the log of 3 to the x would be equal to the log of 9. And using the logarithmic rules, log of 3 to the x can be written as x log 3, and that will be equal to log of 9. And therefore, we can say x is therefore dividing both sides by log 3. Let me just write that in to prevent confusion. Dividing both sides by log 3. Then we get x is equal to the log of 3, the log of 9 rather, divided by the log of 3. And that would give us 2. Now I should point out here that the log of 9 divided by the log of 3 is not the same thing as log of 9 over 3. These are two very different things. And so remember, when you're writing down your logs, that in using the rule, the log of a product is equal to the sum of its logs, and the log of a quotient is equal to the difference of its logs, but you cannot write this log 9 over log 3 as 9 over 3. They're two very different things. So we'll get 2 here, and that's the answer, say what we got over there. And we could also use ln, which is natural log, or log to the base e. So we could say ln of 3 to the x is equal to ln of 9. Why did I write the 9 all the way up there? Let's fix that. Log of 9, ln of 9. And we pronounce both of them the same way, log, ln. So we say x ln 3 is equal to ln of 9, and therefore x is equal to ln of 9 over ln 3. And we would just get our answer just the same. So you'll see that the idea works, that you could write this number in the same base as 3, and you could also solve it using logarithms. Not in every case that you can write it, and so using logs become very, very important, as in this one. 3 to the x minus 1 is equal to 7. We cannot write 7 in base using this as a power of this base. So we have to find another way to do it, and in finding that other way is where the logs come in. So what we're going to do is to say the log of 3 to the x minus 1 is equal to the log of 7. And so we can use logarithmic principles then to rewrite it, to write the power in front as a multiplier. So x minus 1, let's put that in a bracket. Log 3 is equal to log 7. And then dividing both sides by log 3, x minus 1 would be equal to the log of 7 over the log of 3. And our final answer is going to be x is equal to log 7 over log 3 plus 1. Now, this is the exact answer. And if you wanted a decimal version of your answer, you could put that in a calculator. That would give you something like the log 7 divided by log 3 on a calculator would be somewhere 1.77 plus 1. And so that would give you 2.77. I think it's 1.771. But to round it off to 2 decimal places, and there we'd have our answer exactly, and the answer as a decimal. Let's look at a different type of question now. Here we have a question that says the log to the base 4 of x is equal to 2. And to solve this, we simply rewrite it in exponential form. So we're going to take this log equation and rewrite it in exponential form, which is to say 4 to this power. So 4 squared is equal to x. And therefore 16 is equal to x. And that does it. That's it there. So you take this logarithmic equation, rewrite it in exponential form, and same thing applies here. So we'd say 2 raised to the third power is equal to 3x minus 1. 2 to the third is 8. 8 is equal to 3x minus 1, and so 8 plus 1 is equal to 3x. We therefore get 3x is equal to 9, and therefore x is equal to 9 over 3. Which is 3. So the idea here is that sometimes you may have to rewrite your log equation as an exponential equation and sort it out from there. Let's continue now. So sometimes if you have a log equation and you have the same base, then all you have to do is equate these. So we can simply say here, since both of them have the same base, then we say x is equal to 2x minus 1. And just solve this linear equation here and you get your answer. So removing, switching up things up here, we get 1 is equal to 2x minus x. And therefore 1 is equal to x. And that's our solution. So as long as they have the same base, we can go ahead and equate. Now, they will not always be this simple. So the idea is once they have the same base, you can go ahead and equate whatever is here and solve your equation. Let's look at a more challenging one using the same idea. So here we have the ln of 2 plus 2 ln x plus e is equal to ln of x plus 3. And what we want to do is to rewrite this part first as a single log. It helps when you do that. So we would say the ln of 2, this is a power here, so we're saying 2x squared is equal to the ln of x plus 3. Remember, the logarithm of a product is equal to the sum of its logs. So this came from a product, and this is a power, which is why the power goes there. So we can equate them now and say 2x squared is equal to x plus 3. And here we have a quadratic equation that we need to solve. So let's go ahead and solve it by writing it as 2x squared minus x minus 3 equals 0. This equation can be factorized. And so your factors would be 2, 3, 6. It would be 2x squared minus 3x plus 2x minus 3. Of course, you could use the formula or whatever method you want to solve it. And we have here x is x into 2x minus 3 and 1 into 2x minus 3. And so we get for our linear factors x plus 1 and 2x minus 3 equals 0. That translates to being x is equal to negative 1 and x is equal to 3 over 2. Now, when you have a quadratic situation from your log equation and you solve it, you need to make sure you check for what we call extraneous solutions. That is, solutions that are not real and cannot work. So here we have x is equal to negative 1. Now, you cannot use negative numbers in the domain of a log function. So if you should try to put negative 1 in here, it wouldn't work because you'd have a log of -1 here. So that solution wouldn't work. So this is not a solution. So the actual solution that would work for this equation is x is equal to 3/2. So whenever you solve the equations, make sure you check to make sure that there aren't any extraneous solutions in the ones that you find. All right, let's try again. Let's look at another one. Here we have log of x minus 1, log to the base 2 of x minus 1 plus log to the base 2 of x minus 3 is equal to 3. So there's no log written over this side. So let's try first by rewriting this part as a single log. It's a sum, which means that it came from a product. So we say log to the base 2, x minus 1 times x minus 3, and that would give us 3. And therefore, we can use our exponential form of the equation to say 2 to the third is equal to x minus 1, x minus 3, and of course multiplying this out gives us x squared minus 4x plus 3 equal 8. Rearranging this, x squared minus 4x minus 5 equals 0, and solving this equation, 5 would be 5 times 1, which would be x squared minus 5x plus x minus 5 equals 0. Just going through the solution by factoring. So x into x minus 5 and 1 here, x minus 5, and take that up there. So we'd have x plus 1 and x minus 5 equals 0. Again, we can end up here with x is equal to -1 from that, and x is equal to 5 from this. So again, this -1 wouldn't work. If we should put -1 here, we're going to get the log of -2, and it would also give us a negative there. And the idea is that we cannot put negative numbers in the domain of our log functions. You can take your calculator and try it. Just press around with it. You'll realize that you get domain errors. It's because we can't put negative numbers in there. So our solution here is x is equal to 5. So while the quadratic gives you two solutions, this one is what we call, remember, an extraneous solution. So it wouldn't work in that equation. Let's try another one. Same idea. And remember, when you see log, it normally means log to the base 10. If it's not to the base 10, the log will normally be stated there. But once you see log, it's not normally interpreted as log to the base 10. Now here we have a product on this side. So we're going to rewrite it as log of x plus 1, x minus 1 is equal to the log of x plus 2 squared. Remember, this is a power, so it goes back up there. And so what we have here is x plus 1 times x minus 1 is equal to x plus 2 squared. Very good. Now expanding this gives us x squared minus 1 is equal to x squared plus 4x plus 4. And rearranging this equation, we realize that we have x squared minus x squared plus 4x plus 4 plus 1 equals 0. And that tells us that 4x plus 5 is equal to 0. And in trying to solve this, then our x, the value of our x is going to be x is equal to -5/4. Now, if we put -5/4 here, this -5/4 is the same thing as -1 1/4. So if we should put it here, then we are going to end up with a negative here. And as I said before, negative numbers don't work in the domain of a log function. So what's going to happen here is that even though we got a solution from the quadratic, it ends up in a linear equation in the end, but we got a solution and the solution doesn't work in the question. And what it means is that there are no real solutions. So So there is a solution, but the solution doesn't exist in the real number set. Most likely you would have to go to complex numbers to find what that solution is. But however, the idea is that there are no real solutions for this question.